Hello friends, I welcome you on the lecture series on elementary analytic functions. In this lecture, we are going to discuss inverse hyperbolic functions of complex analysis. So first we define some of the inverse hyperbolic functions. So the inverse hyperbolic sine function W equal to sine hyperbolic inverse Z is the relation such that sine hyperbolic W equal to Z. So sine hyperbolic inverse function is the solution to this equation sine hyperbolic W equal to Z. Similarly, the hyperbolic cosine has inverse function cos hyperbolic inverse Z, which is defined by the solution of cos hyperbolic Z cos hyperbolic W equal to Z. So if cos hyperbolic W equal to Z, then this W is nothing but inverse hyperbolic cosine of Z. Similarly, we can define the inverse hyperbolic tangent W equal to tan hyperbolic inverse Z is the relation such that tan hyperbolic W equal to Z. In this way, we can define remaining inverse hyperbolic functions like inverse hyperbolic sec function, cosec function and cot function. So as in the case of inverse trigonometric functions, for this case also we are having the formulas in terms of logarithmic function. So we try to prove this formula, prove that cos hyperbolic inverse Z equal to log of Z plus square root of Z square minus 1. So as we defined, we have to solve this equation. First we assume that cos hyperbolic inverse Z equal to say W. So therefore we have cos hyperbolic W equal to Z. This is by definition. Now if we use the definition of cos hyperbolic function, we can write cos hyperbolic W equal to e raised to W plus e raised to minus W over 2 equal to Z. So this we can rewrite as e raised to W plus 1 upon e raised to W, and this 2 we transfer on right hand side, so it is 2 times Z. Now if we multiply this whole equation by e raised to W, we have square of e raised to W plus 1 equal to 2Z e raised to W. So therefore e raised to W square minus 2Z e raised to W plus 1 equal to 0. So if you observe, this is nothing but quadratic equation in e raised to W, which is quadratic equation in the variable e raised to W. So therefore using the formula for quadratic function, we can have e raised to W equal to minus coefficient of e raised to W, which is minus 2Z, plus or minus square of coefficient of e raised to W, which is minus 2Z square, minus 4 times coefficient of e raised to W square, which is 1, and constant term, which is also 1, over 2 times coefficient of e raised to W square. So therefore we obtain this, we can rewrite as 2Z plus or minus, this is going to be 4Z square minus 4 over 2. Now here we can see 4 can be taken common and square root of 4 is 2. So this we can rewrite as 2Z plus or minus 2 times square root of Z square minus 1 over 2. So we can cancel out 2 and we are left with z plus or minus under root z square minus 1. Now this square root of z square minus 1 is already double valued function. So we can, instead of plus or minus, we can simply write plus square root of z square minus 1, because this is double valued function. So it is not necessary that we write plus or minus both the signs. So here we mention that because it is double valued function, we can ignore negative sign. Now if we use the definition of logarithmic function, we have w equal to log of z plus square root of z square minus 1, and w is nothing but cos hyperbolic inverse z. So finally we are able to prove that cos hyperbolic inverse z is nothing but log of z plus square root of z square minus 1. So we just used the definition and we are able to prove that cos hyperbolic inverse z equal to log of z plus square root of z square minus 1. We have just used the definition of cos hyperbolic w and inverse cos hyperbolic function, and after making this quadratic equation in a raised to w, we are able to find out value of w using the definition of logarithmic function. Similarly, we can prove this type of formula for hyperbolic sine inverse function. So it is similar to that one. If we want to prove this formula, we start by taking sine hyperbolic inverse z equal to w. So by definition, this implies z equal to sine hyperbolic w. Now we use the definition of sine hyperbolic w, which is e raised to w minus e raised to minus w over 2. Now these two we transfer on left hand side, so we have 2z equal to e raised to w, and e raised to minus w is written as 1 upon e raised to w. Now we multiply this equation by e raised to w, so we obtain 2z e raised to w equal to e raised to w square minus 1. And if we transfer this term on right hand side, we have e raised to w square minus 2z e raised to w minus 1 equal to 0, and which is nothing but quadratic equation in e raised to w. So therefore we obtain e raised to w equal to minus coefficient of e raised to w, which is minus 2z, plus or minus square of minus 2z minus 4 times coefficient of e raised to w square, which is 1, into constant term, which is minus 1, over 2 into coefficient of e raised to w square, which is 1. Now we simplify this and we obtain e raised to w equal to 2z plus or minus, this is going to be 4z square, here negative negative positive, so we have 4. And in the next step we can take this 4 outside square root, so we have square root of 4, which is 2, and we are left with square root of z square plus 1. And here again we can cancel out this 2 by taking common from numerator. The numerator has 2 common, so that we can take outside, and that 2 will cancel out with these 2. So we have e raised to w equal to z plus or minus square root of z square plus 1. But this square root of z square plus 1 is double valued function, so we can ignore negative sign here. So we write only positive sign. And then using definition of logarithmic function, e raised to w equal to z plus square root of z square plus 1 implies w equal to log of this right hand side, which is z plus square root of z square plus 1. And our w is nothing but sine hyperbolic inverse z. So sine hyperbolic inverse z is nothing but log of z plus square root of z square plus 1. So here we have square root of z square plus 1, and for cosine function we had square root of z square minus 1. That is the only difference. Cos hyperbolic inverse z equal to log of z plus square root of z square minus 1, and for sine hyperbolic inverse z we have positive sign here. Now we try to prove for tan hyperbolic inverse z. So we have to show that tan hyperbolic inverse z is 1/2 times log of 1 plus z over 1 minus z. So we start by assuming let tan hyperbolic inverse z equal to w. So we have to show that w equal to 1/2 times log of this bracket. So this gives us z equal to tan hyperbolic w, and by definition this is sine hyperbolic w over cos hyperbolic w. So from this we obtain sine hyperbolic w is e raised to w minus e raised to minus w over 2, and cos hyperbolic w is e raised to w plus e raised to minus w over 2. So 2 will cancel out, and if we multiply this numerator and denominator by e raised to w, we have e raised to 2w minus 1 over e raised to 2w plus 1. We are multiplying this numerator and denominator by e raised to w. Now we are interested in the value of w, so we consider this denominator with multiplication on left hand side. So we have z into e raised to 2w plus z equal to e raised to 2w minus 1. We are interested in e raised to 2w, so we take this term on left hand side. So we have z into e raised to 2w minus e raised to 2w equal to minus 1, and we transfer this z on right hand side. So minus 1 minus z. So here we take e raised to 2w common. So we have z minus 1 times e raised to 2w. Here we can take negative sign common. So from this we obtain e raised to 2w equal to negative of 1 plus z over z minus 1. And this negative sign we can adjust with z minus 1. So this we can rewrite as 1 plus z over 1 minus z. We multiply this negative sign with z minus 1, so we obtain 1 minus z. Now by definition of logarithmic function, it is log of 1 plus z over 1 minus z by definition of logarithmic function. So finally we obtain w equal to 1/2 log of 1 plus z over 1 minus z. But w is nothing but tan hyperbolic inverse z. So tan hyperbolic inverse z is nothing but 1/2 log of 1 plus z over 1 minus z. So in this way we can derive the formulas for tan hyperbolic inverse z, and it is in terms of logarithmic function. So using these formulas we can find out values of inverse hyperbolic functions using logarithmic function. So we stop here. In this lecture we have defined inverse hyperbolic functions of complex variables, and we have derived 3 formulas in terms of logarithmic functions. So I hope you like this lecture. Thank you very much.